Kubernetes is an open source container orchestration platform that helps manage containerized applications. It is designed to automate containerized applications deployment, scaling, and management. Understanding Kubernetes architecture is important to thoroughly utilizing its capabilities. The Kubernetes architecture consists of two main components: control plane components and node components. The control plane components manage the cluster's worker nodes and pods. It is responsible for deployment, scheduling, and self-healing of containers. The control plane runs across multiple computers. A cluster usually runs multiple nodes. The node components in a Kubernetes cluster consist of a set of worker machines called nodes that run containerized applications. Every cluster has at least one worker node, and the worker nodes host the pods that are the components of the application workload. The control plane components fully control the node components. The control plane components comprises several key services including Kube API Server, etcd, Kube Scheduler, Kube Controller Manager, and Cloud Controller Manager. The Kube API Server is the most important service and users access the cluster through it. It is designed to scale horizontally to balance traffic. etcd is a highly available key value store that stores cluster data and has a backup plan for data recovery under disaster scenarios. The Kube Scheduler watches for newly created pods with no assigned node and selects a node for them to run on. Factors considered for scheduling include individual and collective resource requirements, hardware, software policy constraints, affinity, anti-affinity specifications, data locality, inter-workload interference, and deadlines. The Kube Controller Manager is a control plane component that runs controller processes. Note that multiple controller processes are compiled into a single binary and run in a single process. This includes node controller, job controller, service account controller, and so on. The Cloud Controller Manager adds cloud-specific control logic to link your cluster to your provider's API. This optional component can be scaled horizontally to improve performance and tolerate failures. The node components comprises kubelet, kubeproxy, and container runtime. The kubelet is an agent that runs on each node in the cluster to ensure containers are running on a pod. It talks to the API server and container runtime to handle starting containers. The kubeproxy is a network proxy that runs on each node in a Kubernetes cluster and is responsible for network communication. The container runtime is responsible for managing the execution and lifecycle of containers within the Kubernetes environment and can be any runtime implementation of Kubernetes CRI. Finally, Kubernetes namespaces divide a cluster into multiple virtual clusters. The initial namespaces are default, kube system, kube public, and kube node lease. Understanding the Kubernetes architecture and its components is critical in efficiently deploying, scaling, and managing containerized applications.